In this video, we are going to talk about the analysis of complex numbers. That is complex analysis. All right. Complex analysis actually is this analysis of complex numbers or complex variables. We also have real analysis that studies or that deals with the analysis of real numbers. All right. So complex analysis, complex numbers. You get the point now. And we shall begin this study by talking about complex mappings. When we say complex mapping, we are actually talking about a transformation. All right, a transformation. Okay, a complex mapping is actually a transformation that takes a point or that takes point from one complex plane, the Z plane. Yeah, from one complex plane, usually the Z plane, to another complex plane, which is the W plane. In complex mappings, two planes are involved, the Z plane and the W plane. Points are taken from this Z plane and mapped onto the W plane. Now look at it. The complex function W equal to f of z, all right, can be interpreted as a complex mapping where z is a point, f is a function. The function takes the point z and maps it onto w, right? We call this the transformation equation. Or we call it transformation function. In this transformation equation, z is a complex variable or a complex number, x plus I, y, right? This is a member of the set of complex number. W itself is also another complex variable or another complex number in terms of u and v. Z is x plus iy, which is a member of the set of complex numbers. W is equal to u plus iv, which is also a member of the set of complex numbers. Now, take note that this is both u and v, they are functions of x and y. So u is a function of x and y. V is also a function of x and y. Now let's say in the z plane I have a point P. The transformation of P onto P prime. P is in the z plane and P prime is in the W plane. The transformation of P in the Z plane onto P prime in the W plane is referred to as a complex mapping of P onto P prime. Under the transformation, W equal to f of z, right? This is very important, the transformation equation. So P is a point in the Z plane and P prime is a point in the W plane. The mapping of P onto P prime is a complex mapping, all right? And this transformation equation is involved. P prime is called the image of P. Image. All right? P prime is the image of P. So we are going to solve some questions now that involves images of complex variables. All right, so let's go ahead. Watch the video to the end. All right, subscribe, like, and share this video to your friends and to your classmates. Let's go ahead. This is the first question we have to solve. Determine the image of the point A, which is in the Z plane. The point A is Z equal to 3 plus I2. On the W plane, under the transformation, W equal to 2Z minus I6. All right. Make sure you watch this video to the end so you don't miss out. All right, because there are a lot of things to say under complex mappings. Let's go ahead. The point A is this: Z equal to 3 plus I2. Okay. Remember the transformation equation or the transformation function that says W equal to f of z. And we said that W is u of x and y plus I into IV of x and y, right? And this is equal to f of z. Now, from the question, W is 2z minus I6. 2z minus I6 is equal to this. U, okay, let me just write U plus IV. Of course, we know that both U and V are functions of x and y, right? Recall that Z is S plus IY. I mentioned that earlier. So in place of Z here, I'm going to write S plus IY. So this is 2 into X plus IY minus I6 equal to U plus IV. Are we getting it now? So if I expand this bracket, it will be 2x plus 2iy or I2y. Let's write it like I2y minus I6 equal to u plus IV. This is 2x. These two are imaginary numbers, so or imaginary variables. I can bring the I out plus I in brackets 2y minus 6 equal to u plus IV, right? So if we compare them, u is equal to 2x because they are both real parts. Then 2y minus 6 is equal to v because they are both imaginary parts. So I'm saying that u is equal to 2x and v is 2y minus 6. 2y minus 6. U is a function of x and y, like we stated earlier. And v also is a function of x and y as 2y minus 6. The question now is, what is x and what is y? You know, we are trying to determine the image of A. Now, let's come back to the point A, which is z equal to 3 plus I2. 3 here is the real part, and 2 here is the imaginary part. Okay, so if we follow this pattern, s plus iy, s corresponds to 3, y corresponds to 2. We are saying that u of what's x 3, what's y 2. What will it be? X is 3, y is 2. If I plug in 3 here, that will be 6. 2 times 3 equal to 6. X is 3, y is 2. Plug in 2 for y, this will be 2 times 2 minus 6. 4 minus 6 is minus 2. So let the image of A be A prime. Let the image of A be A prime. So we were having, the image is this, W equal to, W is U plus IV, alright? W is U plus IV. Z is X plus IY. So U is 6, whilst V is minus 2. So this is simply 6 minus I2. This is the image of A on the W plane. We can try to sketch the graph. Let's attempt to do that. We have the Z plane and we have the W plane. Okay, in the Z plane, we are dealing with 3 plus I2. So I'll plot, let me plot that complex variable. 3 is the X, we have the X and the Y. Okay, this is the Z plane. In the W plane, we also have we now have the U and the V. The U represents the X axis, the V the imaginary axis. Same thing here. X represents the X axis and Y represents the imaginary axis. We have 3 for X and 2 for Y. So 3 for X, 2 for Y. Let's say, let me shift this. This is 3. and this is 2. So if I plot this point, this is point A. You get it? Now let's come to the image. This is the x and this is the y. So x is 6, y is minus 2. Okay, so let's shift it. Let's rearrange it. Let's say this is our 6. This is where 6 is. The minus 2 will be at the negative v, or the negative imaginary axis. Minus 2 is here. So let's plot it. All right, this is A prime. So this is the W plane, and this shows the mapping of A onto A prime under the transformation W equal to F of Z. This is it. So let's take another question. Let's solve another question. Just keep watching. Question here says map the point in the Z plane onto the W plane under the transformation W equal to F of Z. The point we are given is this, and the transformation equation is this. All right. Let's call this point, let's call it B. Z equal to I minus 2. All right. The W is equal to U, which is a function of X and Y. We know that already, plus IV. And this is what? F of Z. Of course, V is also a function of X and Y. Okay, W is 1 minus I into Z plus 3. Before we expand, we know that Z is equal to X plus IY. Z is always X plus IY. So I'm going to write X plus IY here. 1 minus I into X plus IY plus 3 equal to U plus IV. 1 times X is X. 1 times IY is plus IY. 1 times 3 is 3. Minus I times X is minus IX. Minus I times IY is minus I squared Y. Minus I times 3 is minus I3. And this is equal to U plus IV. We proceed by saying X. Okay. Remember a complex number, I squared is equal to minus 1. You know that. So if I squared is equal to minus 1, then if I write minus 1 here, I'll be having something like this. Minus 1 y. I squared is minus 1. So minus minus will give me a plus. So I'm having plus y. This will now become plus y. So this is x. Let me group it. Plus y. Are you there? Plus 3. I'm grouping all real numbers now. I've done that. Plus, let me group the imaginary numbers. We have minus x. Minus x is left here if I remove the I. Then I have y left. And then I have minus 3. This is equal to U plus IV. So if I compare, it means that U is equal to X plus Y plus 3. And V is equal to what? Minus X plus Y minus 3. Okay, U is a function of X and Y. What is X? What is Y? If you come back to the point we are given, Z equal to I minus 2. Minus 2 here is the X because it is a real part. U, function of minus 2, which is X. Y is the coefficient of I, which is 1. So I'll be having minus 2 plus 1 plus 3. Minus 2 plus 1 is minus 1. Minus 1 plus 3 is 3 minus 1, and that's 2. So if we do the same here, V of minus 2 comma 1, X is minus 2. So I'm having minus 2 plus y is 1 minus 3. 1 minus 3 is minus 2, right? So we have plus 2 here. And this one will give us minus 2, and that will give me 0. So let the image of B be B prime. Then we are going to say that W is equal to U plus IV. What is U? U is 2 plus I into V is 0. Of course, 0 times I will give me 0. Therefore, the image is W equal to 2. This is the image of this point Z on the W plane. Let's do this. We have to map the straight line joining point A and B. A is minus 2 plus I and B is 3 plus I6 in the Z plane onto the W plane when W is 3 plus I2Z. Well, first of all, the first thing to do is to determine their images, alright? The image of A and the image of B. That's the first thing. So using the process we used or we followed in example 1 and 2, we are going to follow it here. So I will solve from the beginning to the end. Just keep watching. Now, for A, let's start with A. A is the point Z equal to minus 2 plus I. W is U plus IV, and this is F of Z as always. W is 3 plus I2Z, and this is U plus IV. Z is X plus IY. So this is 3 plus I2 into X plus IY equal to U plus IV. So 3 plus, let's expand, I2 times X is I2X. I2 times IY is I squared 2Y. Okay, and this is equal to U plus IV. I squared is minus 1. So I squared 2Y is actually minus 2Y. And this is equal to U plus IV. Okay, we have, let's group it. 3 and minus 2Y, they are the real variables here. So 3 minus 2Y, then I2X, that's the imaginary part, equal to U plus IV. Therefore, U is equal to 3 minus 2Y. Okay, let's just go ahead. Remember, X is a function of X and Y. So if we come back to this point A, X is minus 2 and Y is 1. The coefficient of I here is 1, so Y is 1. X is minus 2. So U of minus 2 comma 1 is simply 3 into 3 minus 2 times 1. And this is 1. Alright, because Y is 1. There is no X term, so we leave the X minus 2 alone. V is I2X. Sorry, 2X. So V of minus 2 comma 1 will be X is minus 2. So 2 times minus 2 is minus 4. So the image of A, let's call it A prime, is this. W equal to 1 plus I4. Okay, 4 is minus here, so it's minus 4. So W is equal to 1 minus I4. This is the image of A. So let's write it like this. Let's keep this. Following the same procedure, what is the image of B? B is the point Z equal to 3 plus I6. Alright. So let's go ahead. W is U plus IV, and W is still 3 plus I2Z. Okay, Z is X plus IY. Okay, so there's no need to even solve because we are still going to arrive at this, right? Okay, see what I'm going to do now. See what I'm going to do. I6. W is U plus IV. Okay, now W is 3 plus I2Z, right? If I break that down from here, everything here will still flow. because I'm going to repeat the same process here. 3 plus I to Z, Z is still X plus IY. So if I simplify, I will get to this point. So I'm going to get 3 minus 2y plus I2x equal to U plus IV. But the only thing that will now change is this X and Y. We are not using minus 2 and 1. So for B, it is 3 plus I6. That means X is 3, Y is 6. So U is still 3 minus 2Y. U is still 3 minus 2Y. And V is still 2X, right? So we now say U of X is 3. Okay, X is 3 and Y is 6. 3, 6. So this is 3 minus Y will be 6. 2 times 6 is 12. This is minus 9. So U is minus 9. Then V 3, 6. V of 3, 6, that will be 2. X is 3. That will be 6. So the image of B, which is B prime, is W equal to U, which is minus 9, plus IV. So we have gotten the image of A and B respectively. So I'm going to plot a graph now showing these 2 points on the Z plane, and another graph showing these 2 points, this and this, on the W plane. The Z plane for these two, and the W plane for the images. So just watch me. I'm going to do that. All right, let's now graph. We have the Z plane and the W plane, okay? So this is A prime, B, and B prime. On the Z plane, the Y axis and the X axis. For the Y axis, the most negative number is, okay, there is no negative number at all for the Y axis, I6I. Okay, 6 is bigger than 1, so let me raise it up. Let me bring it down. So we have, let's say this is 6 and this is 1. 6 for B, right? 1 for I, 1 for A. Then for the X axis, we have minus 2 and 3. Okay, so let's say minus 2 is here and 3 is here. Let's plot A and B. A is minus 2 plus I, minus 2 plus 1I. It is 1. So it will be here. Minus 2 plus 1I, right? This is A. B is 3 plus I6. 3 plus I6, so this is B. The question told us that it is a straight line. It says we should mark the straight line joining these 2 points. So A and B is a straight line. That's AB. Okay, this is for the Z plane. We are going to the W plane now. Let's see. All right, we have the V axis, negative V and positive V. Okay, minus 4 plus 6. Minus 4 plus 6. So I'm going to give a longer distance, let's say from here to here. So we have minus 6 and we have 4. Okay, let me adjust it. So let's say from this is where we have positive, okay, and negative 4. That's this. Then there is positive 6. Okay. Then for the X axis, which is the U axis rather, we have 1 and minus 9. 1 and minus 9. Okay. So positive 1 is here, negative 9 is over here. Alright, let me adjust this, pardon. So I should do something like this. Since negative 9 is longer from the origin than this other side. So we have positive 1, then here is still -4, and here is +6. I hope you get what I'm doing. So let's plot the image, let's plot the point A prime. A prime is 1 minus I4. +1 minus I4 is in the fourth quadrant. This is A prime. All right. Then we have B prime minus 9 plus I6. Minus 9 plus I6. So this is our B prime. Now, AB is a straight line. Are we going to say that A prime, B prime is another straight line? We are not sure. All right, we are not sure. We can't say it is a straight line. So I can't draw a line from here to here until I verify. So this is the verification stage now. First of all, I will determine the equation of this line in the Cartesian form. If this were to be x and y axis, normal x and y plane in the real axis, this point is a minus 2, comma, then y is 1. Then b will be what? 3, x is 3, then y is 6. So let's use this coordinate now to determine the equation of this line. Using the equation of the line under coordinate geometry, y minus y1 over x minus x1 equals y2 minus y1 over x2 minus x1. Okay, so let's go ahead. Y minus, let's take this as y1, x minus, let's take this as x1, which is minus 2, so that will be plus 2. Y2 is 6, y1 is 1, x2 is 3, minus x1 is minus 2, that will be plus 2. 6 minus 1 is 5, 3 plus 2 is 5, so 5 over 5 is 1. So this is y, this times this is y minus 1, this times this is x plus 2. So we are saying that y is equal to x plus 3. Now, remember we are trying to determine the path, or the path followed by this image. It could be a line or even a curve. It could be a curve. So we cannot just say that it is a line or is a curve. We have to verify. And that's what we are doing now. So what I just did now, I just determined the equation of this line AB in the rectangular form. The transformation equation they gave to us was W equal to 3 plus I2Z. This is the transformation equation we use to determine the images of A and B, right? And we follow the process that says W equal to U plus IV. And W is 3 plus I2Z, which is U plus IV, right? And 3 plus I2 into X plus IY, which is Z, is U plus IV. So 3 plus I2X plus I squared 2Y equal to U plus IV. This is 3 plus I2X minus 2Y, because I squared is minus 1 equal to U plus IV. 3 minus 2Y is equal to U, right? And V, which is 2X, is equal to V. Remember this is what we got. Okay, let me erase this one, write it again. So U is 3 minus 2Y and V is equal to 2X. All right. So what am I going to do with this? U is 3 minus 2Y and V is what? 2X. Okay, see. From this first one, let's call this equation 1, let's call this equation 2. From this equation 1, okay, y is equal to u minus 3 over minus 2, right? If we make y the subject of the formula, which is equal to, the minus will go up to times this 2 to give us 3 minus u all over 2. So this is what y is equal to. From here, equation 2, x is equal to v over 2. This is the rationale. When we got to this point, we determine the Cartesian equation of EB, right? So I am going to remember these two equations for u and v. We solved earlier, we got u equal to 3 minus 2y, v equal to 2x. Remember that. Okay, so what I will do is I will plug in x now is v over 2. I'll put it here. Y is 3 minus u over 2. Put it here. And simplify the resulting equation. So upon simplification of that equation, I will now know whether it is a line or a curve or something else. You get the point now? So having done this now, I want to plug in y is now 3 minus u over 2. So 3 minus u over 2 is here, equal to what's x? V over 2 plus 3. You see, if we do LCM, 3 minus u over 2 will be v. Okay, sorry, this 2 is out. Is equal to v plus 6. 2 times 3 is 6. Do it, LCM, you get it. Now, what is this? This is the equation of a straight line. Okay, if we say we make v the subject of the formula, v will be equal to minus u plus 3 minus 6, right? Minus u is here. 6 cross our terms say minus. So we have v equal to minus u minus 3. This is actually the equation of a straight line. If we are saying, for example, y equal to minus x minus 3, something like this, you get the point now. They are similar. So we are using v and u. It is the equation of a straight line. Something different from y equal to minus x squared minus 3. For example, this is actually a curve, and this is what? A straight line. We have seen that this equation is the equation of a straight line. Therefore, the path followed or traveled by the image is also a straight line. So I can connect these 2 points now, A prime and B prime, with a straight line. So this is actually the transformation. Okay, see, this is B to B prime, then A to A prime. You see it? So from A to A prime, this is the arrow position. It was from A to B before, now from A prime to B prime. That's the arrow. You get the point, is as easy as this. Alright, let's stop here for now. Let's stop here for now. We just began complex analysis, alright? So other videos will come up in the future or subsequently. Hit on the subscribe button right now and turn on notifications to get updated whenever I upload videos. So I appreciate all your viewership and your subscriptions. Like the video and share it with your friends and your classmates. Keep following, keep watching. Stay tuned for the next video.